Alright, we're going to start with the chapter review for chapter 6. And if you look on page 384, you'll see the chapter review. Under lesson 6.1, there's a review example. It says, find the probability of drawing a green marble out of a bag containing 3 red marbles, 5 blue marbles, and 4 green marbles. So, P of a green marble would equal the number of green marbles over the total number of marbles. As you can see, there are 4 green marbles, and if you add 5 and 3 and 4, you get 12. So the total number is 12. So 4 over 12 is also equal to 1 over 3, and that is equal to about 33.3%. Let's look at the problems for lesson 6.1 in the chapter review. There are 2 problems. One deals with theoretical probability and one deals with the odds of an outcome. Alright, number 1 is a probability problem. It says, what is the probability of randomly selecting a brown sock from the drawer? And as you can see at the top, it says a sock drawer contains 6 black socks, 10 white socks, 2 red socks, and 6 brown socks. And it wants to know the probability of randomly selecting a brown sock from the drawer. Okay, we have our probability equation here. P of E equals the total number of favorable outcomes over the total number of possible outcomes. So our total number of favorable outcomes would be the total number of brown socks, because that's what the problem asks for, brown sock. So there are 6 brown socks in the drawer, so that is our total number of favorable outcomes over the total number of possible outcomes. If we add 10 and 6, we get 16, and then 16 and 2 is 18, and then 18 and 6 would be 24. So that would be 6 over 24. Okay, that's our total number of outcomes, and this is our total number of favorable outcomes. And you can reduce this to 1 over 4. 6 goes into 6 one time, 6 goes into 24 4 times, and you know that 1/4 is equal to 25%, or 0.25, and that of course is equal to 25%. So the answer for the probability of getting a brown sock from the sock drawer is a 25% probability. Now let's look at the odds problem, number 2. What are the odds of selecting a white sock without looking? Okay. Now odds are different. They are, the odds of an event is equal to the number of favorable outcomes over the number of unfavorable outcomes. So not the total possible number of outcomes. That's probability. When you're dealing with odds, you're dealing with the denominator being the number of unfavorable outcomes. So the denominator changes here. So now it's talking about randomly selecting a white sock. Okay, and there are 10 white socks. So our total number of favorable outcomes is 10. Alright, and then that is over the number of unfavorable outcomes, which we need to add everything except the white socks. Those are the unfavorable outcomes. So 6 and 2 is 8, and then plus 6 is 14. Okay, so that's over 14. And 10 and 7, you can reduce that. 2 goes into 10 5 times, and 2 goes into 14 7 times. Okay, so that's 5 over 7. And so then, when you write odds, you write them with the numerator first, 5 to 7. So the odds of selecting a white sock without looking are 5 to 7. That's how you read this when you're talking about the odds of an outcome. Okay, for lesson 6.2 in the chapter review, it's on experimental probability. Let's look at the example, the review example. It says a board game manufacturer realized of the 7,280 games purchased, 976 were returned due to missing pieces. Find the experimental probability of buying a game with missing pieces. Okay, so P of the missing pieces is equal to 976 over 7,280. And that's because if you look on page 342, experimental probability, the probability of the event is equal to the number of times the event happens over the total number of trials that you had. And since they made 7,280 games that were purchased, okay, of the 7,280 games that were purchased, that's the number of trials, that's the number that were sold. 976 were returned due to missing pieces. So that 976 is the total number of times that the event happened, the total number of times that a game was returned with missing pieces. And that is equal to about 13.4%. Okay? We will do the review exercises number 3 and 4 in class tomorrow on the 9th, Tuesday, because it requires us to experiment, which is exactly what experimental probability is. So we will do the flipping of a coin tomorrow in class and do numbers 3 and 4 together in your groups in class. Lesson 6.3, let's see, lesson 6.3 is the addition principle of counting. Alright, let's look at the review example. It says a spinner is labeled with 7 red spheres, 5 blue spheres, 2 green spheres, 10 red cubes, 4 blue cubes, and 8 green cubes. What is the probability of landing on a cube or a red shape? Alright, so if you add all of those numbers, 7 plus 5 plus 2 plus 10 plus 4 plus 8, it equals 36 sections. Okay, there's 36 sections, and there are 22 cubes and 17 red shapes. If you look at the problem, you will see that on the spinner. 10 red sections are cubes. So if you look on page 350, it says the addition principle of counting at the top, and it says suppose there are M ways to make a first choice, N ways to make a second choice, and S ways to count the choices twice. Then the number of ways to make the first choice or the second choice is M plus N minus S. Okay, so there are 22, that's your M, plus 17, that's N, and then minus 10, okay, because you added that in twice to the 22 and the 17. That 10 was included in both of those numbers. So you have to subtract it once so that you only include it one time. So 22 plus 17 minus 10 is equal to 29 sections that are either cubes or red. So the P of cube or red equals 29 over the total number, which was 36. Alright, now let's look at numbers 5 and 6. Number 5 says a red number cube and a green number cube are rolled. Find the probability that a red even number and a green odd number are rolled. Alright, so here we have our sample set, our sample space that I created here. As you know, a cube will only have 6 sides. So this, the x-axis represents our red cube, and the y-axis represents our green cube. And as you can see, I created a sample space with points on the graph. And I went over 6 and up 6 because there are 6 faces on the green cube and there are 6 on the red cube. Now we need to find the probability that a red even number and a green odd number are rolled. Now the total number here then is 6 times 6, which is 36. Okay, 36. So the total number of points in the sample space is 36. So we know that's going to be our denominator. Okay, and we just need to find our numerator. Now how do we do that? We find how many points in here represent rolling a red even number and a green odd number. So we'll start with a red even number of 2, and we'll go up to a green odd number 1. So that's 1 point. Okay, 2 and 3 is 2 points, and then 2 and 5 is 3 points. Let's go to our next even number. 4 and 1, that's 4 points. 4 and 3, that's 5 points, and then 4 and 5 is 6 points, and then 6 and 1 is 7 points, 6 and 3 is 8 points, and 6 and 5 is 9 points. So there are 9 points here that represent rolling a red even number and a green odd number. So that's what we're going to put here, 9. Okay, that's our total number of favorable outcomes over the total number of possible outcomes. And if you reduce this, you get 9 goes into 9 one time, and 9 goes into 36 4 times. So we found the probability that a red even number and a green odd number are rolled. It is 1/4. Alright, number 6. Mary is selling raffle tickets. Mary's mother bought 5 raffle tickets, and Mary's aunt bought 10 tickets. There were 500 tickets sold all together. What is the probability that Mary's aunt or Mary's mother will win the raffle? Okay, so the total number of favorable outcomes of the mother or the aunt winning is 15. And the total number of possible outcomes was 500 because there were 500 tickets sold. So 15 out of 500, and then that reduces 5 goes into 15 3 times, and 5 goes into 500 100 times. So that's 3 over 100, which is equal to 3%. So the probability that Mary's aunt or her mother will win the raffle is a 3% probability. Okay, lesson 6.4 is on the fundamental counting principle. This was the lesson where we got to make tree diagrams, so if you look at your chapter review, page 385, lesson 6.4, the review example says Amos has 3 shirts, 2 sweaters, 4 pairs of slacks, and 2 ties. How many possible outfits can he choose from? So, and it says use the fundamental counting principle. If you look on page 356 in your lesson 6.4, you'll see that it says the fundamental counting principle is to find the number of ways to make successive choices in a series of different categories. Multiply together the number of choices in each category. So that's what they did here. On page 385, they had multiplied 3 times 2 times 4 times 2, which gave them 48. So Amos can choose from 48 different outfits. So they simply took the number of each item, the shirts, sweaters, pairs of slacks, and ties, multiplied them together, and got their answer. Let's look at number 7. Okay. Number 7 says a cafe offers 3 choices of soup, 4 choices of bread, and 3 choices of beverage. How many different orders of soup, bread, and beverage are possible? So to figure that out, again, we just use the fundamental counting principle, and we have 3 choices of soup times 4 choices of bread times 3 choices of beverage, which is equal to 3 times 4 is 12, and 12 times 3 is 36. So the total number of different orders of soup, bed, and beverage that are possible are 36. Alright, let's move on to number 8. It says, how many ways can you choose a class president, vice president, and secretary from 15 students? Now this is a bit different. There is an example of this on page 356. Okay, you have 15 students total. When you go to vote for the class president, that's the first thing you're going to vote for. You have all 15 students possible. So that's the first number that you're going to put down, 15. Okay, and you're going to multiply it. Now, when you go to choose your vice president, you no longer have 15 students to choose from because you've already selected one student as the president. So when you go to select the vice president, you only have 14 students to choose from. So that's the next number that you're going to put. Then you're also choosing a secretary. Now you've chosen a president, you've chosen a vice president. When you go to choose your secretary, you don't have 15 students to choose from, you have 13 because you've already chosen 2 students to be your president and your vice president. So now you have your president, your vice president, and your secretary. You multiply these numbers all together and you get 2,730. Okay, and that is how many ways that you can choose a class president, vice president, and a secretary from 15 different students. 2,730 ways of choosing. Alright, lesson 6.5 talks about independent and dependent events. Let's look at the review example on page 385. It says there are 3 red marbles, 4 green marbles, 6 blue marbles, and 3 white marbles in a bag. What is the probability of choosing a green marble and then a blue marble from the bag? So P of green would be would be equal to the green marbles over the total number of marbles. So there are 4 green marbles. The total number of marbles is 16. So that's 4 over 16, which is equal to 1/4. Now P of blue divided by green is equal to the blue marbles over the total left in the bag. Okay, and that is equal to 6 over 15, which is equal to 2/5. And then P of green times P of blue, given that green has occurred, then is 1/4 times 2/5, which is equal to 1/10. Now that is an example of a dependent event. Okay, and then in your review exercises 9 and 10, you have one that is a dependent event and one that is an independent event. Okay, number 9 says a bag contains 5 blue, 3 green, and 4 red marbles. What is the probability of picking 2 red marbles in a row without replacement? Whenever it says without replacement, you know that it's a dependent event because the probability of one event is going to depend on the probability of the other. So the way we figure this out is it says what is the probability of picking 2 red marbles in a row without replacement? So altogether we have 5 plus 3 is 8, and then plus 4 is 12. Okay, so we know that's our denominator. That's the total number for our first problem. And to begin with, there are 4 red marbles. So if the probability for the first time that we pick a marble out, for the probability of picking a red one will be 4 over 12. Right, but here comes the dependent part. And let's go ahead and reduce this. 4 over 12 is equal to 1/3. Okay. Now, here's the the, what am I trying to say, y'all? Here is the dependent part, because now we're going to choose a marble again, and we want to know the probability of choosing another red marble, okay? But we've already chosen this marble, and it says without replacement, so we're not putting this red marble back. So now there are only three red marbles in the bag, and there are only 11 total marbles, okay? So the number of total marbles went down by 1 because we took a red marble out. And then the total of red marbles went down by 1 because we decided the probability of choosing a red marble. So our probability of choosing a red marble on the second time that we choose is 3 over 11. So what we do is we multiply these two. So we have 3 over 11 times 1/3. And when you multiply these two, you get 1 over 11 is our probability of picking two red marbles in a row without replacement. Okay, this is a dependent event, and this is our probability of choosing 2 red marbles without replacing when we choose 2 times. That's 1 over 11. Now, number 10 is going to talk about an independent event. It says a circle is divided into 4 sections labeled 1, 2, 3, and 4. 2 pebbles are dropped on the circle. What is the probability that one of the pebbles lands in section 1 and the other pebble lands in either sections 2 or 4? So there's nothing dependent on anything else here. The circle is the same both times. It doesn't change. So that's why this is an independent event, okay? So the first time that we drop a pebble, we want to know what the probability is that the first pebble lands in section 1, okay? So that's our favorable outcome, it landing in section 1. That's only one section, so it's 1 out of 4 different sections that it could possibly fall in. So the probability of the first pebble landing in section 1 is 1/4, okay? Now, the other pebble, we want to know what the probability is of it landing in either section 2 or 4. So that's, we want to know what the probability is of it landing in 2 of the different sections in the circle. So that's 2 favorable outcomes over the 4 possible in the circle. Okay, we multiply these two together, and we get 1/8. Okay, so the probability of one of the pebbles landing in section 1 and the other pebble landing in either section 2 or 4 is 1/8. Lesson 6.6 is about populations and sampling. If you look at page 385, your lesson 6.6 review example, it says a business owner hired 15 male sales representatives and 10 female sales representatives. About how many female sales representatives would you expect the owner to hire out of 150 sales representatives? So you take your sample of females, which is 10 over 25, is equal to 0.4, okay? And then the population of females then is 0.4 times the number that they gave you of the total number of sales representatives that they would hire, which was 150, and you multiply those two together and you get 60, okay? So they would expect to hire about 60 female sales representatives out of the 150 sales representatives that they do hire. Okay, let's look at your review exercises for lesson 6.6 in your chapter review. Number 11 says, in an assembly line, 2 out of 250 items were defective. Out of the 8,000 items produced, how many would the manager expect to be defective? So the first thing you're going to do in a problem like this is go ahead and 2 out of 250. Okay, you're going to go ahead and divide that. Now, we know that this reduces to 1 over 125. Okay, and when you divide 1 by 125, you get 0.008. Okay, 0.008. This is the first number that you need to get in a problem like this. Okay, it'll say, it'll give you it'll say in an assembly line 2 out of 250 items. So it'll give you that first, something out of something. You divide those and you get a decimal here. Okay, then you're going to multiply this decimal out times the number that they give you for the number of items total produced or total. Okay, so in this particular problem it says out of the 8,000 items produced. Okay, now you're going to multiply this decimal times that 8,000, because that's how many they have produced. And they want to know about how many would the manager expect to be defective. Well, 0.008 times 8,000 is 64. So the manager would expect about 64 items to be defective. Let's look at number 12. In a senior class, 3 out of 25 students want to major in engineering. So we know right away that we need to divide 3 by 25. And 3 divided by 25 is 0.12. Now let's read the rest of our problem. It says out of the 2,500 seniors, about how many are expecting to major in engineering. So now we just multiply 0.12 times the 2,500 seniors. Ooh. Oh my. And that is equal to 300. Okay, so about 300 of the 2,500 seniors we would expect them to major in engineering. About 300 of those would major in engineering about. Okay, so write down any questions you have. I know that you guys will probably view this either tomorrow on the 9th or maybe on the 10th on Wednesday before class on Thursday. We will go over this review in class tomorrow. We'll do on the 9th, we'll do lesson 6.2 review in class, and then on Thursday we'll go over any last minute questions and give the test on Thursday instead of on the 9th, which I think we had said we would, but we'll put it off a little bit because we need to do the review for lesson 6.2 in class and talk about this a little bit. Alright, thank you guys, and I'll see you at class.